everybody, welcome back to Algebra 3. Today we're going to be talking about something called an inverse function. And you might say, okay, well, what is an inverse function? Well, an inverse function is a function that will undo or undoes every operation in the original function. So let's just take this function right here, f of x equals 2 times x plus 3. Well, let's think about the operations that are in this function. Well, the first operation that I can think of, that I could see right off the bat, is the plus 3. So a plus 3 is what happens. And then also and when I say operation, I'm talking about add, subtract, multiply, or divide. So plus 3 is one operation, and then there's also a multiply by 2, like x gets multiplied by 2. So plus 3 and a multiply by 2. So these are the operations that happen for f of x. Well, the inverse function, or the inverse, we'll call it a relation because we're not for sure if it's a function just yet, but the inverse relation or the inverse function, undoes every single operation that the original function does. So if the original function had a plus 3, the inverse relation is going to have a part that's going to involve subtracting 3. Because subtraction is the inverse operation to addition. It will also have an operation that will undo the multiplying by 2. So it will also involve dividing by 2. So what we're going to do today is we are going to look at original functions, and we are going to come up with a formula for an inverse relation or an inverse function, and then we'll look at how that affects the graph. Now there is notation that we do need to be aware of. So if my original function is f of x, then the inverse, we're going to write it like this, f, and it looks like to the negative 1 of x, but we say this out loud, f inverse. Inverse of x. So that's just it's not an exponent, it's just notation for the inverse function. Now, how do we find the formula for the inverse? So what you'll do, you'll follow a set of steps. So how to find the inverse. First thing we're going to do, if you have an f of x notation, you're going to replace the f of x in the original function with a y. So you would just rewrite this by replacing it with y. So I'll just go ahead and do that here. So let's say instead of f of x equals 2x plus 3, y equals 2x plus 3. Then you're going to switch the x and the y. And that's the first time you've actually wrote the inverse yet. It's just not solved yet. So you just switch the places. So instead of y equals 2x plus 3, I will have x equals 2y plus 3. Step 3, you're going to take that new equation and you're going to solve it for y. So for me, I would need to subtract 3 on both sides to get x minus 3 equals 2y. Then I would need to divide everything by 2 to get x minus 3 over 2 equals y. So I solved it for y, and this is what I got. Then the last step is to use my inverse notation. So now you're going to replace the y with that f inverse notation. So now I have x minus 3 over 2 equals my inverse function. Now, hey, didn't I say the inverse relation was going to involve subtracting 3? Look, minus 3. I also said it was going to involve dividing by 2. Divide by 2. And so that's what we're going to do when we find our inverses. So let's go into Delta Math and let's work out a couple of these. Clear this ink. Clear the ink. How do I clear it? Can't find my little button. That's what I'm looking for. I need this to go away. Okay, so here we go. So now I have the function f of x equals x to the 1/3 minus 9. I need to find my inverse. Okay, so first of all, change this to a y. So y equals x to 1/3. Now I do know that x to the 1/3 is the same as the cubed root of x. That might be helpful here. So I have the equation y equals the cubed root of x. Then I'm going to switch x and y. So I have x equals the cubed root of y. After I do that, I need to solve for y. So to solve for y, I need to raise both sides. If I have the cubed root of y, I'm going to raise both sides to the 3rd power to cancel it out. So now I have x cubed equals, when you cube the cubed root, it just cancels. X equals y. Then you're going to replace the new y with your inverse notation function. So I have f inverse of x equals x cubed. Oh no, I have this minus 9 the whole time. Let's fix that. All right, let's try this again then. All right, so I have y equals x to the 1/3 minus 9. There we go. Okay. So now I'm going to switch my x and y. So x equals y to the 1/3 minus 9. After I switch the x and the y, I am going to solve for y. So I can do that by adding 9 both sides. So x plus 9 equals y to the 1/3. Now y to the 1/3 is the same as the cubed root of y. So then to get the y by itself, I can raise both sides to the 3rd power. So that I have x plus 9 to the 3rd power equals y. And then finally, I'll replace the y with my inverse notation. So the inverse of f equals x plus 9 to the 3rd. So then I'll select this one. Let's try another one. This time I have the cubed root of x plus 5 for f of x. So first of all, replace f of x with y. Then you're going to switch the x and y. So x equals the cubed root of y plus 5. Then I need to solve for y. So I can subtract 5 on both sides. X minus 5 equals the cubed root of y. Then I can raise both sides to the third power. X minus 5 to the third equals y. And then replace the y with the inverse notation. So x minus 5 to the third equals the inverse of f of x, which looks like this one. Awesome. Now here in the second section, we have a couple of various functions. It is multiple choice, but I'll still follow the same steps. So replace this with a y, and then replace f of x with y, switch the x and the y, so that now I have x equals 5y to the negative 4/3. I'm going to solve for y, so I can start by dividing both sides by 5. So x over 5 equals y to the negative 4/3. Now, if you're stuck on how to get rid of that negative 4/3, what you can do is you can raise both sides to the reciprocal power. So the reciprocal power means that you flip the fraction. So that means I'm going to raise both sides to the negative 3/4 power. So on the right side, negative 4/3 times negative 3/4, that multiplies to be 1. On the right side, I have x over 5 to the negative 3/4. And I believe that's an option. If I rewrite my y with an inverse notation, I have x over 5 to the negative 3/4. X over 5 to the negative 3/4 looks like I'll pick that one. That mark, but then pick that one. Submit my answer. Yes, let's try one more. Okay, here's another one similar to it. So replace the f of x with the y. Then I'm going to switch my x and my y. X equals 3y to the negative 5 over 2. I can raise both sides to the negative 2/5 reciprocal. So flip the fraction, but you don't change the sign. Still keep it negative. Just flip the fraction. So raise both sides to the negative 2. Oh no! Don't do that. Don't do that yet. Don't do that yet. Don't do that yet. Try again. You gotta isolate that y first, man. So y equals. No, I'm switching switch the x and the y. X equals 3y. Oh no, I was right. To the negative 5/2. I can't divide by the 3 first because the 3 is inside the parentheses. So I do actually need to raise both sides to the 2/5, negative 2/5. We were right. So now I have x to the negative 2/5 equals, on the right side, negative 5/2 times negative 2/5, those cancel. I'm left with 3y. Divide both sides by 3. Now I can divide both sides by the 3. X to the negative 2/5 over 3 equals y, and then replace the y with the inverse notation. it looks like I would pick this last one. Yes. So now in the last section, you are given a graph and we have to graph the inverse. Now, how does the inverse look like the function? Like, we know how to find the algebra formula for the inverse, but what does that do to the graph? So let's take a look at that. So first of all, remember when I said that whenever you are finding the inverse, you have to switch the x and the y. Well, that happens on the graph as well. So let's say this is the graph of f of x, okay? I'm going to pick a couple points on f of x that pop up. So it looks like 5, 0. I'm going to pick some key features like the vertex. This looks like so 5, 0. Wait, I don't want to write that right there. Let's label this f of x. Make an xy chart for f of x. X's and y. So there's a point at 5, 0. There is a point at 9, -2. This line is really crooked. Let's see where there's another point. There's a point at 5, -4. And, oh, we had to plot at least 5, so let me pick 2 more. So let's see. There's a point at 0, 1. And then there's a point at 0, -5. When I go to graph the inverse, I'm going to switch the x and the y. So what that means is every single one of these ordered pairs, I'm going to switch. So instead of the point 5, 0, the inverse is going to have a point at 0, 5. And instead of 9, -2, there'll be another one at -2, 9. Switch these, have a point at -4, 5, and another point at 1, 0, and another point at -5, 0. So let me draw these on here. I'm going to have to erase these points because I think they might be in my way. Okay, so let's say I need a point at 0, 5. I need a point at -2, +9. Point at -4, 5. 1, 0. And then another point at -5, 0. Now, this is my inverse, and I'll submit my answer. Since I made a mistake somewhere, so let's find out where it is. Oh, I plotted this point right. It's supposed to be at 1, 0. So it needs to be at 1, 0. There we go. Now let's try that. Awesome. Switch the x and the y. Now, what does this dotted line mean? This dotted line is a line of symmetry, so anytime you graph an inverse function, it's going to be a reflection. So I should be able to fold this graph along this dotted line, and this parabola should match up perfectly to the other one. Or I could hold a mirror right here, and I would see that graph. So that's what you'll do for each of these. You'll have, I think you have to do 2 of them. So good luck with this assignment.